Hello, everybody. My name is Hassan Sherwani, and welcome to our webinar on incremental data pipeline on data lake architecture. In this webinar, we shall discuss a tool called Data Lake in Databricks and how it could help data scientists, data engineer, and even business team to work in a very unified platform, which is called Databricks. So talking about Delta Lake or Data Lake in Databricks, Delta Lake actually is a storage layer that helps it become more reliable. It integrates streaming and batch data processing while providing ACID. So ACID means autonomicity, consistency, isolation, and durability transaction. And finally, it provides scalability to our metadata handling. Furthermore, it is fully compatible with Apache Spark APIs and run on top of our existing data lake. So let's begin with our introductions. My name is Hassan Shirwani, and I am working as practice head of data science. I have been working with Royal Sabre around a year. So at my work, I love experimenting with different models and their optimization algorithms. However, I was a bit surprised to see how these models never see light of our day, and they deserve more work on them. Moreover, I was also kind of overwhelmed by the knowledge of data engineering and how much less effort is being given to data engineering domain. So in Royal Cyber, we are working on end-to-end machine learning project approach that is from data collection to application, that is starting from data cleaning to model implementation. This gives me a lot of satisfaction to see real-time data being sorted and sorted out, and also seeing our data science projects being actually becoming a product. So my colleague Omar Amanat is here. Omar, would you like to go ahead?
Yes, Sasan, sure. So my name is Muhammad Umar Amanat, and I'm working as a senior data scientist in Royal Cyber. So my day-to-day job routine consists of creating end-to-end machine learning data pipeline and also monitoring the machine learning pipeline using the state-of-the-art available tools like ML, Flow, and many more. So, but my role is not limited to the data science. I'm also working with the data engineering team to create modern data warehouse and modern data lake architectures where we are utilizing the power of Databricks to create a lakehouse architectures which fully utilized by the data science team, advanced analytics teams, and provides a tons of benefits on to the top of the business. So this is about me. Further about Royal Sabre. So Hassan, I would like you to introduce about the Royal Sabre. Then we will move toward our proper session.
Sure. So, about us, we are a company of around 1,000 plus members. We are located in 8 plus location around the globe. We have a very strong cloud expertise, having around 300 cloud experts, and most of them are actually certified. We keep very diverse cloud portfolio in terms of our certifications, such as AWS, GCP, Azure, and IBM. We have also a large open source practice where we work with open source tool sets to solve machine learning and data science challenges where we can actually help you out. So if you want to know more about us and more about Royal Cyber details, please shoot us an email and we'll love to tell you more about our practice. Thank you.
Thank you, Hassan. Okay, now we are moving toward the agenda. So the agenda is here. First, we will start with the problem overview. And in problem overview, I will give you the detail about the current problems, and then we will move toward the solutions. Before moving toward the solution, we will talk a little bit about the Databricks Lakehouse architectures, how it is different from its competitors, its benefits, and in terms of cost, in terms of maintenance and management. After the Databricks Lakehouse Architecture, the main topic of this session, which is incremental data challenges, how to deal with what are those challenges and what are the solutions for those challenges. In solution, first we will talk about solution we will create at our own, their pros and cons. Then we'll move toward what is the solution provided by the Databricks Lakehouse architectures. And after the solution, we will discuss a little bit about the architectures which will solve the this case. And at the end, little bit about question and answering. We will be welcome to answers your questions. Okay, now move toward the problem overview. The problem overview is simple. Video streaming business, which is interested in creating modern data architectures. Why from they are going for modern data architecture? Because they want to introduce advanced data analytics in their business. There are few and number of advantages for the modern data architectures. Few are like you are able to do machine learning, data science on your data. Your Power BI team can utilize a standard and single source of truth which is available for all the teams. Your Power BI teams can create dashboards. Your data analyst can come up with the fruitful insight which will help in strategizing the business. But when we are going moving toward creating a modern data architecture, we first need to solve some prereq, and there are a number of prereq, but few are the questions which is confined around the data. So few of questions are what is the format of data? Like it is CSV, JSON, Parquet, Avro, or what type of format? We need to sort out first format of data. Then is it batch or streaming data? Because for creating a data pipeline for batch, for streaming data, they have different ways of creating. And later on, we will merge the data from different sources, although in a single data lake. But to ingest streaming and batch data, we need to create different data pipelines. And it can be both. In some modern use cases, as business are moving toward the streaming, so they are introducing the streaming into their business, and they are go with the hybrid approach in which they are dealing with the streaming as well as the batch data. And third one is the frequency of data arrival. What is the frequency of new data? Like the new data come in hourly basis, in minutes, seconds, daily. What type of frequency of your data? Because on the when we are decided that this is the frequency of data, according to frequency, we scheduled our job. So this is why frequency is important. And also one of the major concern when we are dealing with data problem is how to accommodate a new data. For example, if the new data arrives, so what are your strategy to deal with the new data? Either you need to drop, if your business objective allow you, you can drop, but mostly we cannot miss any data. We cannot drop any data. So in this session, this is the major concern that how we are going to accommodate new data in our current pipeline. Little bit about data. So the answer for the previous questions in our problem case is that the data is of type CSV and JSON. We have CSV data for the videos, and the metadata for those videos is in JSON form. And as you see in the picture, the JSON contain a nested data type, and the CSV also contains records, and these both CSV and JSONs are multi-line. Multi-line mean that in a single line you have the multiple rows. Okay, so next is it batch or streaming? In our case, it is batch data, and the frequency is daily. It's mean we need to schedule our job on daily basis. Next, let's talk about the Databricks Lakehouse architecture. Why it is famous, why mostly people use it in their business. The best thing about it, it is a unified data analytic platform. What is meant by the unified data analytics? It is a single platform where you can do everything's related to the data. Either it is data engineering, either it is data analytics, either it is reportings, or you can also do ML and data science using the Databricks. So this is why it is a unified data analytics platform. So don't confuse it with the database because it is a unified data analytics platforms, not for the transactional processing stuff. So as I told you, it handles all data, either it is simple data analytics or AI use cases. And other thing why Databricks is famous because it is built using the open source tools because Delta Lake is open and the ML flow library which they use for the tracking of machine learning model is open source and many other services which you can use in Databricks all are open source and you are welcome to contribute. So this is why the contribution from the different organization from different peoples helps Databricks in becoming a robust platform for unified data analytics platform. Okay, about Delta Lake. Delta Lake is not again. Mostly people confuses Delta Lake with the database, data warehouse. It is not a database or warehouse. It is a storage layer which Databricks create on top of data lake. For example, as here show in the image, in the beneath you have the data lake, and on the top of the data lake, the Databricks create a delta lake layer, which bring the acid and other benefits into your data lake, as told by the Hassan. So why Delta Lake is important? Because traditional data lake is not able to, it does not have ACID property. And for example, a simple use case, you are doing some transaction on your data and due to some reason your job crashes. So it's mean your transaction is not ACID according to the ACID property. So your job may gonna corrupt your data if it fails abruptly. This is why we need to bring ACID property for the safe transaction and for the other benefits as well. So this is the one of the best advantages of Delta Lake. And again, it is open format storage layers, and you can contribute it according to your business requirement, and it is built on the behind the scene. It uses the Apache Spark, and the Databricks claim that their Apache Spark engine is faster as compared to the other uh, services provided by the different vendors, and they are according to their claim. So the Apache Spark under the hood brings a lot of benefits to your data. Okay, let's talk about our problems, which is the main concern here is incremental data challenge. You first create data pipelines or code which bring all your data into data lake. And first you succeed according to your objective. But what if new CSV or new data file arrive? How you are going to accommodate in your current pipelines? And there are a number of problems associated with the newly arrival of incremental data. First is how you are going to detect a new data. In that case, is CSV. So how you're going to detect new CSV if you are using the data lake as a first step from where your Databricks is going to read, then how you're going to make sure you are able to you will detect new files. And if you write your own code and able to detect the new file, then what you are going to do with the new file? Either you are going to drop or use it. If you are going to drop, then you're losing the information. And if you are going to keep it, then how you're going to merge into your data? There should be some strategy, there should be some plan. So these are few challenges which are associated with the incremental data pipeline. And also there are solutions. The first solution, which you create your a pipeline which initially load the data. Let's say you rerun that pipeline again, but that pipeline code have some cons. What are those cons? You are going to introduce duplication in your data. So again, you need to solve one thing, but there is a new problem arises. And other than this, there is also another approach, do it yourself. And do it yourself approach mean you are going to create a little infrastructure which deal with the this incremental challenge. But Again, there are some cons, and we will discuss it. First, you need to do a few things. For example, create a mechanism to detect the new files. You need to devise some strategy how you're going to merge the data. Your solution should be scaled as you are doing for the data, and maybe in future you have to deal with the big data. So your solution should be scaled. And cost is the main concern when you're building any solution. So your solution should be cost effective. And at the end, when you solve all this, at the end you come up with the to write a lot of boilerplate code. And also you need to manage all those code at your own. So you, for the simple solution or complex, you're adding more problems, and then you are getting more solution and you are creating more problems. Why so complex? Why we are not going for the simple? The simple approach is autoloader, and it is recently provided by the Databricks, and the autoloader is a tremendous tool which solve your incremental data challenges. It is like a file watcher, which is continuously, you can treat as continuously watching your directory in which new files arrives. And once the new file arrives, behind the scene, the autoloader is maintaining a queue, and in the queue, it has all the informations that what are the files which were already processed and what are the new files. And in that approach, no new file will be missed. So you have the confidence that no new data will be missed. You know about the new data, and next step is upon you how you're going to deal with it. Once we use the autoloader to create entire data pipelines, we need to orchestrate it. So here, as shown in the image, these small boxes are known as tasks in the Databricks jargon, and these tasks are the Databricks notebook. For example, click ingest, which is ingesting data from some source, is a notebook, and you treat as a task when you are orchestrating entire pipeline. So this diagram is entire pipeline, which is showing that the first you have the click ingest, then at the step two you have two notebook, and these two notebook provide data to the third step, which only have one notebook, and in the fourth you have again one notebook which is providing data to the different notebooks or steps. So this is a glimpse of what is the Databricks jobs, what is the Databricks pipeline. So you can create easily via Databricks UI. I can show you it in later in this session. But this job has few advantages. You can create a Databricks notebook using the Python, PySpark, or SQL, and you can run entire your ETL workload or ELT workload interactively or on basis of schedule. So in our cases, like in the current session, we can schedule it according to the business objective. What is the business objective? That the data arrived on daily basis, so we can schedule it on daily basis. So our entire pipeline will be run in ubiquitous way, and we can generate the alert. Either it is success, fail. Mostly we create alert on failure, so it will generate alert if your job's gonna be failed due to some reason. So you will be aware of what is the reason of your job failed, so you can correct it. And you can create the Databricks jobs using the UI, using the Databricks CLI, or by invoking the Databricks on jobs API. It's depend on you. Um, According to your workload, you can use the UI, but if you're using the UI, I think most of time, in my experience, I use the UI. So I barely use the Databricks CLI or jobs API to create it or to automate based on some dynamics. Okay, the next is architecture diagram. This is the architecture which we are going to implement in this session. The architecture is simple. First, we have the data lake. In data lake, we are ingesting our new CSV on daily basis. For example, when we started the job at the first, we have only 10 CSV, and at the next day, 11 CSV arrives. Then our autoloader automatically detect it what is the newest CSV file, and then after autoloader we will ingest using the autoloader data into our notebooks, and these notebooks in the streaming fashion process all the data incrementally, and this architecture makes sure that no file will be missed, no duplication will be introduced, because autoloader behind the scene is using the streaming. So our first notebook, which is data collection, is can be treated as a bronze level notebook. So bronze, silver, gold is nothing, just a fancy name for the archived and refined data. So bronze is a low refined data, silver is further refined, and the gold is fully refined data. Because here we are using the data lake, so the purpose of data lake is to ingest all your structure or unstructured data into some storage. So no data should be missed, and from those bronze layer you process data according to your different requirement. For example, if I need to create a data pipeline for my machine learning team, I can do some transformations according to the machine learning teams and then provide the silver level data to our machine learning teams. And if there is, if we need to show some dashboard or visualization to our executives, then what we will do, we will create a fully refined layer, which is gold layer, and this gold layer provide data directly to our Power BI, Tableau, or whatever visualization tool you have. You can connect it with gold layer, because layer that contains the mostly aggregated level data, so you don't need to do again the transformation. So this is why it's a faster query when you are querying the gold level data tables. Okay, so once we have the data in the bronze layer, then we will move toward the silver step. And at the silver, we will do some transformation, uh, may convert our data into some structure, because the bronze level data does not have any structure. I can show you in this session later that why bronze level data does not have structure. Then once we have the structured data in silver layer, from silver layer, we can do some aggregation to create a gold level uh, database tables. Sorry, not a database, tables, which we can, which will be utilized by the uh, data science or different teams. Okay, so this is about architecture. Let's move toward implementations in Databricks. So the first is the data collection notebook. Data collection is bronze level notebook which just pull the data. Like here, I'm pulling the data and then stored into some table. One thing you need to focus here is that I'm using the cloud files. So cloud files is the autoloader in Databricks. So by adding these three lines, your Databricks Spark engine can detect new files, because Delta engine or Spark engine behind the scene will utilize the autoloader to automatically detect the new files and only process those files instead of previously already processed file. So in the same way, I'm using the autoloader, because my data file is CSV. This can be JSON, Avro, Parquet, or multiple famous format. And I'm doing some pre-processing, like header equal to true, because my CSV contains first line as a header, and delimiter. Sometime if you are going to read tab separated file, so you need to mention here uh, tab instead of comma, so your delta engine aware of that what kind of file and how to parse. So multi-line equal to true mean my CSV file contain some column which have data in multiple rows. So this is necessary in case of JSON, in case of CSV file where your some column contains more than data in more than 2 or 3 rows. And I'm going to infer column types from CSV file, because autoloader by default infer all the columns as a string in order to make your pipeline uh, free from crash, because string pipeline can accommodate all type of data which can be integers, float, boolean. So this is why autoloader by default fetch data in a string format, but you can pass your own schema, or if you want to automatically infer schema, so you can set this flag equal to true. And here is my path, and this path is on Azure Data Lake. So my YouTube data directory contain two folders. The first is the data, and the second is the metadata. Data folder contain the videos data in CSV format, and regarding the metadata for those file is in this metadata folder, and this metadata folder contain the files in JSON format. So this is my raw data which I'm going to fed into the first bronze layer. Then from that point, my transformation silver transformation notebook will come and process and clean those data. Okay, now move back to the bronze notebook. And this is the trigger available now equal to true. We need to set this flag when we are going to read data in a triggered fashion. So there is a difference between the trigger and the continuous. Continuous mean that your notebook is continue running all the day and you need to stop it manually. By setting available now equal to true mean you instruct your Databricks notebook that fetch all the data which is not uh, processed yet, and then processed all the data. After processing, automatically shut down the cluster. So this is why I use the trigger available now equal to true, because I don't need to keep my stream running after the processing of data. And while you're creating the streaming, because autoloader or utilizes the part structure streaming, you need to mention the checkpoint, and this checkpoint will help us in making sure that how many data we have already processed and what new data we need to process. So merge schema equal to true because I'm fetching the raw data. So I don't know about the schema. So if one day I have 10 column, maybe next day in data there is only 5 columns. So in that case, in order to crash my job should be the robust enough to treat different schema. So this is why I set this flag. And at the end, I'm registering this data into my bronze layer. And because I'm using the path, it is external table. So difference between the external tables and managed table is that when you accidentally delete data in Databricks using SQL command, so if the table is unmanaged or external table, so your data associated with that table will not be deleted. You are manually managing that data. So in case of managed data, if you accidentally delete the table, so the data associated with that table also be deleted. So in production cases, we mostly use the external table because we cannot uh, rely on some new developer who accidentally delete our tables, which eventually in the loss of the data. So we need to make sure that our table should be external in case of production. So all these steps will be performed for the metadata, because our metadata is the same as like the CSV, but the different is the format of file format, which is JSON. Otherwise, rest is the same. Okay, now move to the silver transformation. In silver, we need to in silver layer we need to create clean our data first. Then another transformation like removing the null values, standardizing data, all these kind of transformation we apply in silver layer. So the silver layer data should be in structure format. Otherwise, there is no benefit of using the Medallion architecture. Okay, so because I created the bronze data already in data bronze, so the reason why I'm not running this notebook, because at the end I will create all this notebook in a pipeline. So right now I'm just going through a code. At the end we will run all those notebook in a single click because we created a pipeline. Okay, so when we print the schema of this file, so let me run this notebook for demonstration of schema. Our schema is not in the format which is required by the business, and this schema it is in the like in the different column format. For example, our video ID column is in the string, and if you see the trending date, which is in string, but this trending date should be in date format, because when we are going to aggregate data later, so most of time we apply group by on date. This is why trending date data should be in date format. This code transform my unstructured data into the structure, and how it makes sure the column type, because I'm enforcing the schema here, and I am converting the string or different format type to the format the business required for the later stages. So for example, the first is trending date. I convert this trending date into the date format, and this is the function this is the functions of PySpark. So I am porting all the function as f as a the what you can name for the, instead of using the function dot, so I just call the f dot. So this is why I imported the function as f, and f dot call will call the call functions in the PySpark. So this code will convert my unstructured schema into structured. In the same way, I need to parse the format of my JSON, because my JSON data is also in nested form. So I need to parse it manually. Like the items is an array, and in an array we have multiple elements, and inside the single element we have these different values. Inside that element of array we have an other object or dictionary like object, so we need to parse this as well. So this is why I write this function which parse my JSON and convert my JSON structure into the structure that I need for to in order to apply aggregations or group by. Okay, so if you observe something that here I'm creating the temporary views. Why I'm creating the temporary views? Because this is the intermediate step. I don't need to write this data. Instead, I need to save this data in some memory or in some a graph form. So later when I run my code, so this will be treated as a placeholder. So if you register table instead of creating a temporary view, so it's mean you are putting extra cost on your storage layer. So if something is not required, so don't need to write in a tables or registered as a table. So it's better to write all the intermediate step in temporary views. So these temporary views associated with this single session. So inside this session, other user can access it unless I did not apply some constraint on it. And in this way, I can share my logic with my other teammate as well. In the final step, I'm merging my these two table, which is the clean data and the metadata tables. And then I stored into the table, because this is the table I want to store and which can be utilized for the later purpose. And how why I'm going to use the write stream here instead of, because this is a table, there is a reason why I'm using the write stream. The reason is that I'm going to run entire pipeline in a streaming fashion, and in a single go, I want to incrementally update all my new data and merge into already processed data. So I want to treat my pipeline as a stream. So it So it like a smoothly data flow from raw data till to process and fully refined data into gold table. And again, I'm using the trigger available now equal to true. So this will process only the new data, which is not previously processed, and then stored or merged with the new data and create a data silver table. So this is the silver transformation. And at the end, we have the gold transformation. So gold transformation is nothing, it's just a aggregation of data. Like here, I'm aggregating the data using by reading data from silver layer and apply some group by or aggregated function. Like here, I'm grouping my data based on country code, and I want to generate in particular country how many people viewed videos. So it will give me idea which in which country mostly people using YouTube to watch videos. So this table is the video per country, and again I'm writing it as a stream because I want to treat this table as a stream. So for smooth flow of data from start till end. And whenever we are creating the stream data, we also need to provide the checkpoint, and this checkpoint can make sure the what is the status of our streaming data. And this checkpoint can be used by the Delta engine to detect the new data. So like the videos per country, I created another table which is popular videos categories, and again grouping the videos data based on video category or titles, and then I'm apply count function on video ID. So this data will give me idea which category, which video category watched most by the user. This category can be music, entertainment, trailer, movies, and many more. And while I'm doing the aggregation at the end, I'm registering this table in the data in the meta store of the Databricks. And also I'm creating the external table. Why? Because this is my production table. Okay, now move toward the pipeline. So I have already created the pipeline. It's to create this pipeline is a simple. Just need to go to the jobs, create a new job, name the you, for the first task I can name it task 1, because this is of type notebook. As I already told you, this can be of multiple execution environment like jar, spark, python, can like a .py file. If you create all your entire pipeline in a python package, you can also provide the python wheel. But right now, as I created the notebook, so I will select the notebook, and in the path we need to provide the notebook path. So I've created all my notebook in here. So it will know the path. And so when you're creating a data pipeline, so it's depend on you. Either you want to run on already created cluster, or for the safer side, if you are not limited in terms of resource, you can create a new cluster which can spin up on the go and automatically shut down. So you just need to pay for uh, the resource which utilizes in terms of seconds. So if your job run for 1 hour, you need to pay only for 1 hour. You can also parameterize your pipeline. For example, if I'm creating a dynamic pipeline which need to uh, which need to know the current timestamp of my uh, system, I can parameterize it by providing the key and the value, which in that case value will be the timestamp. Okay, so you will click the create and it will make the pipeline. I'm not going to create again because I already have created the my pipeline. And this is the flow of my data. First, I will utilize the bronze notebook, then the data will become into the silver stage, and at the end, the gold stage will create fully refined data. Okay, for the result check, I created this notebook in order to know the new data. So right now we have 3 countries data which we already processed. I'm going to ingest the new data, and then we will run again this whole pipeline. So Right now, I have three country data, France, Canada, and the Denmark. What we need to do for the new data, I need to manually upload in the data. I need to upload CSV file, and CSV file is in my system. I've created this video short because this file is in 51 MB. So to save our time, I've just minimize or reduce the record to reduce the size in KBs. It will instantly upload. Okay, that's great. Now we need to upload the metadata as well because we are joining our data based on the metadata. We need to provide the metadata as well. Uh, we push the GB videos CSV. For this, we need to create the GB category ID JSON, upload it. Okay. Now the new data is arrived, and how Databricks make sure of this new data using the autoloader, because my first bronze layer using the autoloader, so it should automatically detect the new file. Okay, let's run this notebook. We can schedule this pipeline, and if you want to trigger it manually, you can use the run now function. Otherwise, we can create a schedule. And for this schedule, I need to schedule based on minute, hour, day, month, or week. For the day, you need to provide the time at what time your pipeline should run. And according to your time zone, set the time zone here and then click the save. Otherwise, if you are a pro Linux core programmer, you can use the clone syntax as well. Okay, for now, I have not created a schedule because I need to trigger this manually. I don't have any requirement to schedule it. To view the latest run of my pipeline, I just need to click the run latest run of my data job. And here you see that the first my data ingestion notebook is running as it shows the spinner. If I click on it, it will give you the idea that what cell have run so far. So currently it is running this cell because this is the trigger available now equal to true. So this is why this automatically shut down the stream. Otherwise, this stream is will be run in continuous fashion, and your cluster will not be terminate until you terminate it manually. So according to your business objective, you need to make sure what kind of trigger you are required for creating a streaming pipeline. In the same way, it run in a matter of seconds. After the bronze, currently it is running the silver stage. And if I click this notebook, I will debug it further that which cell is currently running. So currently it is running, it is running the finally cell which combine or join the data. For further debugging, we can also uh, click the job like in entire pipeline, how many numbers and which query is running, which is the advanced level concept. We don't need to demonstrate it right now because this is not the purpose. And right now the purpose is just to create incremental pipeline. Okay, it will take some time because it's merging data, and this data is coming from two different sources and of two different type. This is why this may take some minute. And in the right side, we can monitor the entire durations because currently our pipeline is in running mode. Okay, now the execution move toward the final notebook. This final notebook is the gold layer, and we are running the first aggregated data. And one and other interesting thing I forget. while your streaming data is up or running, you can also execute other notebook cell as well. For example, this notebook already ran previously to this cell because this is the streaming or by streaming data. So this will take a while. So meanwhile, your notebook can be utilized in interactive fashion. So if I want to, if for example, for some use cases, there is a limitation, we cannot run next cell until our stream is complete. We can add a single line await termination. So our notebook will await for the new data until it processed it. And now we need for the last cell. Okay, our entire job is succeeded. It will mark with the tick sign. And if something failed, you will got the notification that your job failed and kindly check what is the error. Now we need to run this table again. You see that previously we don't have the GBR gate pretrained data, and because we manually push the new file, autoloader automatically detect and my pipeline only fetch the new data. The previous data remain still. My notebook or my pipeline did not touch the previous data. It only processed the new data. So this is all concept of incremental data pipelines in Delta Lake, and you orchestrate entire autoloader pipeline, and we run it just with a single click, or we can schedule it. Okay, it's time for Q&A, but before Q&A, we can take a break of 2 minutes. Meanwhile, I can give you an exclusive webinar offer. It's a kickstart your assessment with Royal Cyber, a 3 hour of assessment, gap analysis for any new or existing functionality. It is an assessment of your existing applications. 3 hour include your review of documentation, understanding the business requirement, and elaborate on how Royal Cyber is going to implement these processes to solve your business challenges. So to consider this offer, Royal Cyber would like to contribute towards the growth of your business.